Hello, we are team number 1. Our team project title is Virtual Try-On VITON. Our members are Wang, Yujin, and Xintong. To create an online shopping environment close to reality, virtual try-on technology has attracted a lot of interest recently. In our project, we are going to replicate the paper for virtual try-on via machine learning. Before explaining, let me show a video, the traditional way, and our target result of virtual try-on system. As video shows, our virtual try-on system needs to, firstly, retain body shape and pose naturally. Secondly, reserve characteristics of target clothes, for example, pattern or logo on t-shirt. And thirdly, eliminate old clothes and replace with target clothes properly. And finally, retain non-relevant clothes. For example, if we target to change the t-shirt, the pants should be remained without any change like this video. Our target paper to replicate is CVPR, toward characteristic preserving image-based virtual try-on network by Bochao, Wang. The main contribution of this paper to focus on reserving characteristics of clothes, for solving the problems of previous work, reducing the details of the clothes. As figure shows, compared to prior works, VITON, CP-VITON reserved printing on t-shirt. In order for a higher resolution of the target clothes, it proposes the two steps of network. The first network is Geometric Matching Module, GMM. It trains transformation parameters of the clothes. Geometric Matching Modules network's input is person and clothes, and the output is warped clothes, changed properly to fit the person. The second network is Try-On Module, TOM, which generates the final result, person within the clothes. Firstly, it generates mask M and person image IR. Mask M is the region of the new clothes. And finally, it fuses the person and warped clothes from the GMM and creates the result. So to sum, Try-On module, the input is person and warped clothes from the first network GMM, and the output is person wearing the warped clothes. Overall, CP-VITON consists of two networks, GMM and TOM, which we are going to replicate. Next presenter will explain relay works to CP-VITON, which we are going to compare with.
Okay, so start with the previous work first. VITON is a prior version of CP-VITON, so it uses generator and refinement stage rather than GMM and TOM models. Generator stage is similar to TOM model, so it generates the first image. And then in refinement stage, the cloth image is warped and then merged to generate the final image. But this kind of coarse to fine approach has a problem because the warping itself is vulnerable to the generated mask. So the detailed clothes, those details are merged and blurred. So CP-VITON came up with the GMM idea, so simply just changing the two steps, warping the image from the image itself, not with the generated mask. And the other paper, LA-VITON, it's an enhanced version of CP-VITON, especially on the enhancement on the GMM model's loss function. The two concepts are added. The first one is grid interval inconsistency, and then the other one is occlusion handling. Grid interval consistency is based on the assumption that in the real cloth, it is not warped drastically as much. And the occlusion handling is that cloth sections, hidden section by the hair, the hand, those are also taken into account. So for our replication, we chose CPVTON paper. The reasons are, first, we have a base code, but it's actually not an official one, and it also has a lot of problem, which is different from the original paper, so we need to work on running the code itself. Second is that CPVTON introduced the GMMTOM approach, which is widely used in the virtual try-on networks. So also as our future approach, we could use as a baseline. Okay, then we'll talk about the improvement approach.
One of the problems in VITON is artifact in non-ROI. For example, the purpose of VITON is changing a top, but the VITON generates artifacts in pence in final image. That is caused by the fact that the final image is composed by intermediate generated image by GAN in try-on module. Therefore, we modify try-on module in order to estimate another mask for preserving pixels from the original image. Specifically, the original try-on module only extracts a region to be replaced by warped closed image as visualized in orange arrows. But we add another mask to estimate the region to be changed by the original source image as it is shown in red. We expect the method will alleviate the artifacts in non-ROI, which enhances the general performance of generating images. We have Jalando dataset, which consists of pairs of clothed images and the human image wearing the clothes. Totally 16,000 pairs exist, and we divide the data into train set and validation set to evaluate VITON. In addition, we also extract another information for the data, such as masking image of clothes, human passing information, and human pose information by using related previous work. We start to verify re-implemented code of CPVTON. We expect a series of testing and debugging processes. After setting CPVTON as baseline, we implement our idea to improve the performance of generated images through extensive experiments. If time is allowed, we also perform the qualitative evaluation through a human experiment using Amazon Mechanical Turk, which is the most popular method to evaluate the performance of generated images. Thank you.